Chapter 15, Part 5, Thermal Expansion of Water. In the last part, we explained that almost all materials, even liquids, expand when they are heated and contract when they are cooled. However, ice-cold water does the opposite. Let's try to explain this. Water at 0 degrees Celsius, the freezing point, or called the melting ice point, contract when the temperature increases. That's opposite to what you expect. Usually, any material, when it's heated, when the temperature increases, it expands. However, water at 0 degrees Celsius contracts when the temperature is increasing. This strange behavior continues until the temperature reaches 4 degrees Celsius. After that, normal behavior starts and water starts to expand. Expansion continues all the way to the boiling point. Look at this graph. You can see that at 0 degrees Celsius, look at the volume. This is just a representation of volume. When the temperature increases from 0 degrees Celsius to 4 degrees Celsius, the volume decreases, that is, contracts. After 4 degrees, the volume will expand. So this means if you have any amount of water, it will have the smallest volume at 4 degrees Celsius, which means that, if you remember about density, density will be the highest. So, after water has turned to ice, now, a given amount of water has its smallest volume and largest density at 4 degrees Celsius. So water will have the largest density at 4 degrees Celsius. However, the same amount of water, if it's cooled to 0 degrees Celsius, becomes ice. But then ice will have smaller density than water at 4 degrees Celsius. Now you may wonder why water is behaving this way. In fact, it has to do with its crystal structure. So the crystals of most solids are structured so that the solid state occupies a smaller volume than the liquid. However, ice has open structured crystals due to the shape of the molecules and the strength of the forces binding these molecules. Now, water molecules in this open structure, they occupy a greater volume than they do in the liquid state. And that's why the volume of ice is larger and the density becomes smaller. You can see this in this picture. You can see that water, H2O, in the liquid state, look at the molecules, they are a little bit seem closer. Once water becomes ice, look at the picture on the right, you can see that because of this structure of the ice, the volume will increase. When ice melts, some crystals will remain in the ice-water mixture. Now, the behavior of water is of a great importance in nature. Think about it. Suppose that the largest density of water happens at the freezing point at 0 degrees, which we know is not correct. So what will happen in this case? Because the density is high, so ice in that case, it will settle down to the bottom of lakes and ponds, which means the bottom surface or the part will freeze. And this means all living creatures in the pond will be destroyed and killed. However, this is not true, and ice has a smaller density, and so it will float to the surface. When you cool a pond in winter, in cold winter, of course, most of the cooling will happen at the surface because that's closer to the air, to the cold air. Now, as the surface water is cooled, then it becomes dense. It will have larger density and it will settle down in the water state. So water will only float at the surface only if it has a smaller density than the water below. Let's explain this to be more clear. So let's say, for example, you have a pond in winter. Initially, the temperature of the pond, let's say 10 degrees Celsius. Now, the air is cold and the air will start to cool the pond. The temperature of the pond will go down. However, the temperature of the pond cannot go to 0 degrees without first being cooled to 4 degrees. Now, once water reaches 4 degrees, it will have a high density. So it cannot remain at the surface of the water. So it will go down. So ice cannot form in the pond until all the water in the pond is cooled to 4 degrees. Once the temperature of the pond reaches 4 degrees, further cooling will happen and ice will start to form, which has a smaller density and will start floating to the surface of the pond. You can see from this picture, the surface of the pond is icy at 0 degrees Celsius, but if you go down and looking down, you can see that you have a liquid water and the temperature of the water reaching only 4 degrees Celsius. So the water at the surface has to freeze first. Continue cooling of the pond will result in a freezing of the water next to the ice, so a pond freezes from the surface downward. Of course, in colder winter, the ice will be thicker than in a milder winter. Very deep amounts of water are not icy even in the coldest winters, because all the water in a lake must be cooled to 4 degrees Celsius before ice is formed. And because, as we explained earlier, that water has higher specific heat and it keeps its heat for longer time, the bottom of the deep lakes in cold regions will remain at constant 4 degrees Celsius. Usually winter is not that long to freeze or to lower the temperature below 4 degrees Celsius for a large body of water.